Hello everyone and welcome on this Getting Started with GHEtool Cloud edition Summer 2025 video. My name is Wouter Peer and I'm the founder and main developer of GHEtool Cloud. And the goal of today's video is really go over how you set up an account in GHEtool, how you create your first projects and what functionalities the tool has to offer you. So the goal is to give you an overview of everything. It will be a rather long video, but we will specifically not go into detail about the different options. So that's the goal of today, and that's why we already are on the website of GHEtool. Before we jump into it, I just want to point out our knowledge base. So whenever there is a topic in this video that you have more questions about, you can visit our knowledge base. We have tons of articles about tutorials of GHEtool. We have exercises. We have information general about ground source heat pumps, physics backgrounds, and every article has its own YouTube tutorial with more information. So if you have questions, you can find most of them on the knowledge base. But first, let's go to the cloud and really start creating your own project. So this is the login page of GHEtool Cloud. If you're new, you can simply register your account for free. You always get a 14-day trial period without any restrictions. So let me go ahead and do this real quick. So now an email has been sent to my email address. I will validate my account and I come back to you in a second. So I clicked on the link in my email and now I can confirm my email. And now we're in GHEtool Cloud. Now, as you can see, there is this orange bar on the top and I cannot add a new project. So I first need to start my trial license by clicking here. And then you have two options. We offer 14-day full access to all new users, but, and this is an important thing, if you start your trial and also schedule a demo with me, where we can go over the tool and how it can be of value for you and for your company, we will extend it for another 14 days. Now, just let us go ahead, start my trial period, the bar turns green, and I now have 14 days to try everything out. Now, before we create a project, I want to point out we have here some personal information. You can reset your password, etc. And over in our admin dashboard, you can create a company. And after you have created a company, you can also order a license. Here, you can add users to your company. You have settings related to your custom templates for your reporting, etc. So let us go ahead and create our first project in GHEtool. Now you can always, or there are three different ways in which you can add a new project. Either you can start with a blank project. You can start with a template. So if you have a previous project you marked as a template, you can start from that, or you can simply start from a previous project. But since there is no previous project, we need to start with a blank one. Let's call this my first project. Let's go ahead and create it. So now we're in the GHEtool Cloud interface, in the project itself. And I first want to go to the project dashboard. Here you have some general information. You have information about the project. You have some report settings. We will cover that later in this video. You can download or generate your report. And here you have a list of all the scenarios. It's also shown on the left. So GHEtool is really scenario based. This means that whenever you're doing geothermal calculations, you typically want to do multiple calculations and compare different designs. And that's basically what you do in scenarios. So if we go ahead and go to the first scenario, we can fill in all this information. Afterwards, we perhaps want to change certain things. Then we duplicate the scenario, we create a new one, and we can alter information there. And so we can keep track of all the changes we've made. Now, within a scenario, what can you do? Well, quite a lot. GHEtool is more than simply calculating the temperature profile of the bore field. It's really about giving you all the tools needed to really design smaller and bigger geothermal systems with the highest degree of accuracy which is possible. So first you have to select what you want to use this scenario for, what you want to calculate. So typically this is you calculate your temperature profile. This means you have your loads, you have your design, and you calculate how the ground temperature evolves. The second option is if you have a certain design and you want to calculate how deep you should drill in order to fulfill your whole building demand, you can calculate the required borehole depth. The last option is really has to do with optimization. And it's when you, for example, have a limited space for your project or limited budget and you drill too small a bore field basically, then it can calculate what percentage of your building demand you can actually fulfill with this bore field and what should be placed onto another hybrid system. So it's really powerful for bigger projects, fifth generation district heating and all that sort of projects. For the first scenario, let's just keep to calculating a temperature profile. We have some report settings, so we can say, well, we include or does not include this scenario in the report. Based on what we can calculate, we can select different sections we want in the report. Let's go not too much in detail about that. We can add a description of each scenario. Simulation parameters. All the simulations are done with a minimum and maximum average fluid temperature, a certain simulation period, and the first month of the simulation, which typically is by default is January. And then depending on the aim you have selected, you have some specific options. So this first one is an important one. By default is yes. I would suggest always leaving it at yes. It's basically GHEtool updates the fluid viscosity, etc. at every step of the simulation. And this gives you the highest degree of accuracy when it comes to the borehole resistance and your fluid temperatures. If you, for example, want to compare GHEtool to other software, we're rather unique in this accuracy, then you can set it to no to be able to compare it with other tools. But if you want to make an accurate design, you can leave it to yes. Hybrid system we will cover in a second. And below we have also our hydraulic design. So every license in GHEtool comes with also pressure drop calculations. So whenever you do a simulation, you have both thermal and hydraulic results, which is really, really powerful and easy. So this is everything you can find on the first page. Let's just take away this bar on top. For the ground parameters, you can enter this in either a homogeneous way, basically saying the whole ground is one big layer with an average conductivity and an average ground volumetric heat capacity. For the temperature, you can select a database with all sorts of locations in Europe. You can enter the temperature directly if you have measured it by, for example, a TRT measurement. Or you can work with a surface temperature, a geothermal flux, or gradients you enter manually. Let's stick with the temperature database for now. Next to that, you also have the option to work with ground layers. Now, if you have a very diverse ground, with, for example, first sand and then a rock layer, and you're working with calculating the required borehole depth, it can be useful to fill in the ground layers because you have a way more accurate result in the end, because it will update the conductivity internally. So that's something to keep in mind. To save time, let's go for the homogeneous option, and then we can move to the bore field design. Now in GHEtool, we do not work with pre-configured bore fields. We have total design flexibility up to 5,000 boreholes. If you need more, just contact me. There is no limit. Of course, we have some standard configurations to get you started. So for example, we have here a rectangular field, we have a dense field, where the boreholes are hexagonally spaced, box-shaped, L-shaped, U-shaped, and you can even upload it coordinate-wise. So if you draw it on a map, if you draw it in AutoCAD, just export the coordinates, you can import it. Every borehole can have a different depth, can have a different buried depth, and GHEtool can even handle inclined boreholes. So there is really quite a lot of design flexibility there. Let's go back to the rectangular for a second. For our case, I will use a 1x4 grid with 6 meters of borehole spacing. You can change it both in length and width direction, the borehole depth. We also have a buried depth. This is also not included in all software. It's the depth at which your borehole really starts. So it's the depth at which your horizontal piping is installed. Typically it's between 0.5 and 1 meter below the ground surface, but if you're drilling a bore field under a building, it can be easily 4 to 5 meters. So this is also for increased accuracy. And this is basically everything for the bore field. So you can design it however you want. Also, just to point it out, if you, for example, have a complicated bore field like this and you say, well, this borehole we cannot drill, you can click on it, you can convert it to a manual bore field, and then you can delete these coordinates, for example. So it's really, really flexible. Okay, let's stick to the 4 boreholes for now. For borehole resistance, again, quite a lot of options, quite a lot of flexibility. First of all, you can say, well, perhaps it's measured. Now you've done a TRT test, you know this value, but typically you calculate it. And then you have some parameters for the borehole internals. We have all sorts of heat exchangers in here. We have some pre-configured ones, but you can also define your own. We have commercial products like the separatus. We have the turbo collector from Movitech, and more will be added in the future. Number of pipes, grout thermal conductivity, where the pipes are placed in the borehole, etc. Then on the other side we have our fluid data. So if you want to compare it to other software, you can select custom data, you can enter the parameters manually, but we suggest to use water with antifreeze mixture, because then we can use the model of the fluid and we can give you a way more accurate result. So there are some antifreezes implemented here, others will be added in the near future. Let's, for example, use 25% of monopropylene glycol, which gives us a freezing protection of -11 degrees. You can enter your flow rate for the entire borehole or for the entire bore field, depending on how you want to simulate. So let's work with 0.3 liters per second for a single borehole. Let's go to our thermal demand tab, which is our last tab. And here we enter basically what we want to get thermally from the bore field. So you can either say, well, our load is a building load, meaning the information we enter is the heating and cooling demand of the building. If we say, well, I just want to enter what comes out of the ground directly, which is the primary load, it's a geothermal load, you can see that the heat pump data is indeed disabled. You're working directly with the ground load. So for our building, we also have absolute and relative loads, which means, for example, if it's absolute, you have 48 values to enter, the peak power in every month, in heating and cooling, as well as the base load energy in kilowatt hours. But typically you work with a relative load, where this is a standard profile. You can update it and save it as a template if you want. Then you just have to enter your maximum peak power in heating and cooling, as well as your yearly energy demand, and it will automatically spread this out. We also have the option to add domestic hot water on a yearly basis. So this you can also do here. Now if you have an hourly simulation of your project, we will cover that later in this video, you can easily upload it here and you can work with that. So that's also really easy. Let's go ahead and calculate. So if you press calculate, it will be sent to our calculation server, where it will start up a server specifically for your project. And you get the results rather fast. So what do we see here? We have some report settings. Again, it's really easy because you can, for example, type some information you see or how you interpret these graphs manually. We have some numerical results where you see that we have, for example, a Reynolds number, which is laminar in extraction, but during heat injection, during cooling. We have a transient number, we have a temperature profile. We have information for our hydraulic design, the pressure drop. We have a Sankey diagram to see how the energy flows through our system. And there are all information buttons with some more detailed information on what's visible on this graph, and also hyperlinks to articles in our knowledge base. You can export this temperature profile, so it's really, really flexible. Now, let us go ahead, and this was a first scenario. Let's duplicate this and let us, for example, now calculate the required borehole depth. So what we did here is we simulated it for a total of 4 boreholes. Let us now go ahead and say, well, calculate my required depth. So what it will do here, it will vary the borehole depth until the fluid temperatures stay within the 2 to 17 degrees temperature limits. It stays between these two thresholds. And depending on basically your cooling load, typically, this can take somewhat longer to find the real optimum here. So this is the result. We see that we need 4 boreholes of 126 meters, total borehole length of 504, to really keep it within the temperature limits of 17 and 2 degrees. So this is basically how you design simple projects, residential projects, feasibility studies. It's really easy to do. Let us now go somewhat deeper and look at more complicated projects and functionalities of GHEtool. So let's go ahead and do something with hourly data, for example. So let's go back to here, say calculate temperature profile, but for a thermal demand, I will now just upload an hourly load profile. Let's use this one. We select the columns. So I have 2 columns in my file, heating, cooling. Let's go ahead and import this. And as you can see, already some options pop up. So we now have the option to combine active and passive. We will come back to that. But first, let's make my bore field a little bit bigger because it's a rather big project we're going to simulate. So again, this is sent to the server. And this is the result we end up with. So we here have an hourly temperature profile. You can also zoom in to really see the hourly resolution here. The other information is the same. We have the hourly load. So this is the load profile of the building itself. We have the load duration curve. The other graphs are the same. But with this type of high resolution simulation, we can now do quite a lot. So let's make a 4th scenario and, for example, work with active and passive cooling. So we see here that we cross the temperature limit. We said, well, let's work with 17 degrees as a maximum. We cross this limit. So perhaps it's hard to meet our cooling demands with just passive cooling. What we then can do is, under our thermal demand settings, we can say, well, let's combine active and passive cooling. Then we say, okay, for passive cooling, the SEER is typically around 20. It's just a circulation pump running, so it's a really good efficiency. Active cooling, it's typically 5 to 7, so let's take 6. And then we can say, okay, Do we want active cooling during certain months, for example in the central changeover system? Or do we want to simulate that it's active above a certain threshold or below a certain threshold? So here we're going to simulate with the threshold. So if we say the temperature is above 17, we will do it active, and otherwise we will do it passively. And just for the sake of clearness, I'm going to enter this or increase this value so we have a better view of our final temperature profile. So this is our result. We again see here our temperature profile with now a limit at 25 degrees and some extra graphs. So let's go ahead to the value below. Here you see that in our case we have quite a lot of passive cooling power installed and active cooling, but almost all the cooling demand is done passively. And you can see year after year that the share of active cooling actually literally goes to 0. And this is due to the imbalance, of course. The ground cools down, so year after year we don't need the active cooling that much. You also see it on this graph, where you just have a couple of hours in the year where there is active cooling required. For the other hours, passive cooling is enough. So this is how you can work with active and passive cooling in GHEtool. Now, another option is to simulate hybrid systems. Now, let's go ahead and do that. So I duplicated this scenario. Let's call it scenario 5. Simulate hybrid system. So here I'm going to say, well, just use it passively. I go back to my general tab. And now since we're working with an hourly load, put it back to 17. Don't need that. We have the option to add a hybrid system. Now, GHEtool is focused around the design of the ground source. So we do not really care what your hybrid system is. If it's a gas boiler, it's an air source heat pump, is it waste heat? It does not really matter. So when we're calculating a temperature profile and we're adding a hybrid system, this tab opens up. And what it basically does is you upload a weather file, and based on the outside temperature, you can add certain hybrid systems. For example, you can say, well, if my outside temperature is above 12 degrees, well, I have X kilowatts of a certain technology that will be used primarily. For example, if you have an air source heat pump, which is typically more efficient above 12 to 15 degrees outside for heating, you can say, okay, let's use 100 kilowatts above 12 degrees C. This you can also do below a certain threshold and above. So this is how you simulate these systems. Let me just go ahead and do that, for example. I'm going to upload a weather profile. So just an EPW weather profile. You also have the option here to set a maximum power for your bore field. So if you say, okay, let's limit the geothermal power I installed to certain demand, it will also tell you what the excess energy is. Let's now simulate. Let's use this as well. For example, let's say we have only installed 500 kilowatts in cooling. For heating, we will install also just put in a big number. Let's go ahead and simulate this again. So what this will do, it will basically first calculate what the hybrid system will do, and then it will simulate your temperature profile. So this is a temperature profile we have with a load duration, visual power, and here you see the monthly energy balance. So what you see here is what part is geothermal heating and what part is hybrid heating above the threshold, which was what we said when it's above, what did we say? When it's above 12 degrees, we first want to use another technology, and that's the orange bar you see here. Then we have our blue bars for cooling and a very small axis for cooling. Basically, since we did not install the around 700 kilowatts in cooling, with only 500, part of the load cannot be delivered, which is this axis cooling. You also see that here on an energy graph, geothermal heating is used for 95% of the total heating demand. We use a hybrid system of 5%, and for cooling, since we did not install the full 700 kilowatt, we see that less than 1% cannot be fulfilled. You also see that here on your energy graph, where you have your heating demand, which is now delivered by both the ground source heat pump and partly by the hybrid heating system. And for cooling, it's the same. It's passive cooling mostly, but we also have a very small share of hybrid system cooling. So this is how you can quickly simulate hybrid systems. Now, the last big aim of GHEtool is really to optimize your system. So let's go ahead and call this scenario 6 optimize. And perhaps, just for clearness, I will say this is required depth. So for the optimization aim, we will go back to our general tab and we go to our optimize load profile. So here you see there are quite a lot of different fluid options, aim specific options. So when you optimize your load profile, what we will do is we will say, okay, how much geothermal share can be put onto this bore field? And we can maximize this in 3 different ways. We can maximize either the power from your bore field, you can either maximize the energy or the balance. So that are the 3 different ways to do this. You can see whether you want the result of the simulation in a monthly or an hourly profile. Monthly is slightly faster, but the results are basically the same, it's just the way it's represented. And you can also limit your geothermal power manually. So let us go ahead, decrease the bore field a little bit in size, make it 7 boreholes, and let's now optimize for power. So what it will do now, and this simulation can sometimes take a couple of seconds to a couple of minutes. It will try to find the maximum power in heating and cooling you can put onto this bore field so that you still stay within the temperature limits. So instead of simulating the profile, what we did before is where we say, okay, we have this weather profile, we have this weather profile, we have this hybrid system that works below or above a certain threshold, simulate what the result will be. Here we're really going to optimize the result. So this is the result. We see that we optimize the load so that we really are within the temperature limits. You see here your load duration curve, where the hatched area is actually what you can get from your bore field. The non-hatched area is our hybrid system. Here you see it also in circle diagrams, where the hybrid system is available, has 42% of the installed power and is available for 12% of the yearly heating demand. Again, our Sankey diagram shows our hybrid system cooling and our hybrid system heating here, and it's visually pleasing to see how the energy through your system is actually flowing. So this is for the optimize for power. Let me go ahead and perhaps just do it also for energy, so you get a little bit the sense of the different methods. So if we do it for energy, let's go ahead and see our energy. What we now will do is we will slightly oversize our ground source heat pump so that we can tap into the potential you have in the other years. So if you go back to our results, you see that we touched the limits in the first and the last year, but in the years before, especially in the first years, we could add some more ground source heat pump power and extract more energy in these first years. And for cooling, it's the same, but then in the last years. So that's exactly what the optimized energy method does. So it maximizes the energy exchange with the ground. And this is the result we end up with. And as you can see, we now reach the temperature limits in every month of the simulation period, instead of just in the first and the last year. So this means that we have a higher share in geothermal energy, but we also have more power we need to install to really tap into this potential the first years, for example. We also have another graph, namely to show you how the energy you can get from the ground varies over the simulation period, because the ground cools down, so your heating potential goes down over the years, but your cooling potential goes up, which is what you see here. The amount of energy in heating you get from the ground versus in cooling, it changes over time. Now, if this all goes a little bit quick, there are videos linked in the description related to all the different methods. Quite a lot of information out there. I just wanted to show you what's possible and what type of powerful and good systems you can design with GHEtool. Now the last thing I want to show you is that we can automatically export everything to a PDF document. So let's go ahead and do that. So let's call it my first report. You can add an introduction and conclusion. We have at the moment 3 different languages, but we're working on more. You have 2 types of report, really short summary, where we just summarize all the calculations we did, as well as a full report. Let me go ahead and generate the report. And we have the report here. Let's open it. As you can see, it's rather long in this case. We have all table of contents summary. We have a summary of all the simulations. We have the ground data, which is the same. We have all the results, and then we have appendices. So if I just scroll through it, you have an introduction you can write yourself. Summary is just the inputs, the loads, the results. This for all the different simulations we did. For all the simulations, you can also have the results, the general information, the coordinates, the cross-section, the fluid data, the load data, monthly profile, etc., etc., etc. So it's really, really extensive. There is information there, there's hints there is theoretical background. So quite a lot of detail ready to send to your client. So this was everything I wanted to say to you today to really get you started with GHEtool. I hope I showed you how powerful it is. There were quite a lot of more details to tell you about accuracy, about options, about models. I would suggest read through the articles over on our website. Contact me if you have any questions. Schedule a demo call to see how your company can really benefit from using GHEtool as well. And I'm really much looking forward to seeing you in a next video. Take care. Bye.